Beyond the crepuscular hour, let's take a walk among the stars. Let's start by looking at the constellation of Orion. It's a familiar constellation, easily identifiable in the night sky. Suppose I were to ask the question, as we are looking at it, does the constellation of Orion really exist? Let's take a look at the star Betelgeuse, which is on Orion's left shoulder. Betelgeuse, in terms of real size, is the biggest object you will see in the night sky. As you're looking at it, does Betelgeuse really exist? And what about Rigel, which is diametrically opposite Betelgeuse? It is a very luminous object, shines as brightly as about 60,000 suns. As we are looking at Rigel, does it really exist in the night sky as we are looking at it? And what about all the other stars in the night sky? Before we can answer this question, we must make a digression and take a look at light. Now, light, as you know, travels at an incredibly fast speed, 186,000 miles a second, or 200,000 kilometers per second. To get an idea of how large a number this is, if you could travel as fast as light, you could make round trips between New York and Los Angeles about 60 times in 1 second, the time it takes to snap your fingers. So that's how fast light travels, 186,000 miles a second. So to find out how many miles light travels in a minute, you would multiply that number by 60. To find out what distance it travels in 1 hour, you would multiply that number again by 60. To find out how far it travels in 1 day, you would multiply the result by 24. And to find out how far light travels in 1 year, you would multiply the result by 365. If you did the arithmetic, you would arrive at a number which is 5,880,000,000,000 miles. Now that is a huge number, but it's very useful in astronomy because we can use that as a unit of measurement, and we call it 1 light year. The closest star to us, which is Alpha Centauri, we cannot see it from our hemisphere, but if you were in the southern hemisphere, you could see Alpha Centauri. Now that star, which is the closest to us, is 4.2 light years away. What this means is that light from Alpha Centauri takes 4.2 years to get to us. Now, let's go back to the constellation of Orion and let's take a look at Betelgeuse. Now, Betelgeuse is at 640 light years, and the star Rigel is nearly twice as far, so it is sitting at a distance of about 1,200 light years. So when you go outside and look at the constellation of Orion, what you are seeing when you're looking at Betelgeuse, what you're seeing is the light that left that star 640 years ago. In the case of Rigel, you're looking at light that left that star almost 1,200 years ago. If something cataclysmic were to happen to Betelgeuse, let's say it exploded, we will never find that out because the light of that explosion will take 640 years to reach us. So when we are looking at the night sky, We are looking at objects as they existed in different aspects of time. Betelgeuse is 640 years old as we are looking at it. And Rigel is about 1,200. We are looking at Rigel as it was 1,200 years ago. And Betelgeuse, we are looking at it as it was 640 years ago. Let's take our sun. If someone were to ask you, is the sun shining outside? Is the sun shining at this moment? To be very accurate, your response should be, based on the visual evidence, the sun was shining 8.3 minutes ago. The reason I say 8.3 minutes is because the sun is 8.3 light minutes away. When we see the light from the sun, at this moment, we are looking at light that left the sun 8.3 minutes ago. If something happens to the sun, we will not find out about it for another 8.3 minutes. So when we look at the fabric of the sky, of objects in the sky, we are looking at different chapters in history, and we are actually looking at the past, not just so many years ago, but we are looking at various aspects of the past as it was at various different times. So the entire canvas of the night sky is a shimmering reality of illusions.